Hello, how are you? Today I give you some information about titanium. Thanks for watching. What is titanium? Titanium is a non-magnetic silvery metal with the chemical symbol Ti. It is resistant to corrosion and has a very high strength to weight ratio. Titanium is predominantly associated with the minerals rutile and ilmenite, Table 1. Titanium is used mainly as titanium dioxide for white pigments. Interesting uses of titanium. At Titanium Industries, we work with many manufacturers, engineers, and designers that use titanium in a wide variety of products and projects. Titanium is extremely tough yet lightweight, boasting the highest strength to weight ratio of any structural metal. It takes far less titanium to produce a structure that matches the same strength of other metals. If individual plates of the same weight were made from titanium, copper, and stainless steel, the titanium plate would be double the size of the copper, and 75% larger than the stainless steel. Conversely, you could buy half as much titanium to do the same job as copper, and slightly more than half as much to do the same job as stainless steel. The equipment and capability in our warehouse gives us the flexibility to meet a wide variety of customer needs, and so we get to see a huge range of these applications from simple weight reduction to advanced body implants. Firstly, what is titanium alloy? A titanium alloy is a type of metallic or chemical alloy that consists primarily of titanium in combination with other metals or chemical elements that are dispersed throughout the material. The material is synthesized through the precise combination of titanium with various metals and chemical constituents. Once the appropriate ratio has been achieved, the mixture is permitted to undergo the cooling process. Typically, titanium alloy comprises small amounts of aluminum, niobium, tantalum, molybdenum, vanadium, zirconium, manganese, iron, nickel, chromium, cobalt, and copper. 1 Titanium in the aerospace market. The State Route 71 Blackbird warplane was the first aircraft to use titanium alloys extensively in its structure and skin. The aerodynamic friction that resulted from the intense speeds of which the aircraft was capable created so much aerodynamic friction that if any other metal was used, it would simply melt out of the sky. In fact, it was so fast, that if anyone fired a surface-to-air missile at it, the standard evasive procedure was to simply accelerate and outrun it. Holding the record of the fastest aircraft in the world for over 30 years, the Blackbird reached speeds of 3,500 kilometers an hour, or 3 times the speed of sound. Today, about 2/3 of all titanium metal produced is used in aircraft engines and frames. As an example, the A380 Airbus uses approximately 70 tons of titanium for the aircraft structure and fittings. 2 Titanium in medical devices. Titanium is one of the most biocompatible metals. The human body can handle it in large doses with no impact. In fact, it is estimated that we ingest around 0.8 milligrams of titanium a day. Most passes through us without being absorbed. Also, its density is very similar to human bone, which will readily adhere to it. These qualities make titanium alloy 6Al4V Eli grade 23 perfect for use in surgical implants, such as hip balls, sockets, joint replacements, heart stents, and dental implants. Lasting in excess of 20 years with no effects, titanium round bar is a clear choice in the medical field. Its high strength to weight ratio also makes it the perfect choice for surgical instruments and other medical devices. Wheelchairs made from titanium provide the lightest weight, yet are very strong, and children's wheelchairs can be made to grow as the child becomes older. 3 Titanium in everyday products. Surprisingly, of all the mined and synthetic titanium minerals, approximately only 5% is used to produce titanium metal. The remaining 95% is used to manufacture pure titanium dioxides, a pigment that enhances brightness and opacity in paints and inks, paper, and plastics, and even in food products and cosmetics. It's also the metal used in the body of Apple's PowerBook line, helping achieve a lightweight frame. For titanium art/architecture, titanium spontaneously forms a hard protective oxide film upon contact with any oxygen. It is this film that gives the metal its trademark shine and shimmer, with variations in the film's thickness affecting the color that the metal projects. It also has remarkable elasticity, making it the metal of choice for artistic and architectural structures. For instance, the 40M, 131-foot memorial to Yuri Gagarin, the first man to travel in space, in Moscow, is made of titanium 4. The metal's attractive color and association with rocketry. The Guggenheim Museum, Bilbao is sheathed in titanium panels. It can also be used to help structural repair of historic buildings. Titanium was used as a part of the 2008 structural repair and stabilization for the Leaning Tower of Pisa in Italy. The artist who chose titanium for the Olympic torch cauldron said he chose the metal for two reasons: its modern image of superior technology and its beautiful colors when heat treated. Titanium Industries donated the titanium panels that were used in a 9/11 memorial monument to commemorate all those who lost their lives in the Twin Towers tragedy. 5. Titanium in sporting products. The high strength-to-weight ratio of titanium makes it ideal for use in a wide range of sporting equipment. Titanium is a core material in the components of the world's lightest bicycle, which weighs only 6 pounds. Considering an average adult bike weighs 30 pounds and racing bikes weigh around 15 pounds, this bike is extremely lightweight thanks to its titanium structure. The number one consumer of titanium for sporting goods is in manufacture of golf club heads. Most manufacturers such as TaylorMade, Cobra, Ping and Integra have a titanium line. Titanium is also naturally resistant to corrosion and erosion, making it a great choice for safety equipment. When the 6,000 bolts that secured the daring climbing track in Tunsai first started to erode, they were replaced with stainless steel. However, the stainless steel replacements only lasted 9 months, after which they had a corrosion problem that would break the bolt on a simple body weight charge. Metallurgists discovered that the only metal the climbers could trust with their lives was titanium. An average of 2,000 climbers use this track per week, and a group of keen climbers have started a charity to replace all the bolts with titanium along the entire length of the route. More of it has 5 common uses in everyday life. Golf clubs. Titanium is often used in golf clubs because it is both strong and lightweight. Jewelry. Titanium is a popular choice for jewelry because it is strong and hypoallergenic. Dental implants. Eyeglass frames. Cookware. Titanium has no harm to human body, has good biocompatibility and incomparable stability, and will not produce allergy after long-term contact with human body. It is the only metal that has no effect on human autonomic nerves and taste. But it has different disadvantages. The primary disadvantage of titanium from a manufacturing and engineering perspective is its high reactivity, which means it has to be managed differently during all stages of its production. Impurities introduced during the Kroll process, VAR, or machining were once near impossible to remove. The EPR process has reduced this risk, but it does not come cheap. It is not suited in high temperature ranges, above 400 degrees Celsius, where it begins to lose its strength, and nickel-based superalloys are better equipped to handle the conditions. It is incredibly important to use the right cutting tools, speeds, and feeds during machining. Other Metals can be relatively forgiving, but titanium is not. If you get it right, you will have nothing to worry about it. Titanium does have negative externalities which require mitigation. The issues regarding the extraction processes of titanium ores are well publicized. Depending on location, trees are often clear-cut to access bedrock. This can contribute to soil degradation and cause the escape of heavy metals into the soil, which can, if not adequately addressed, pose a significant risk of drinking water contamination. Whilst we are in no danger of running out of titanium, the expense and negative externalities of its extraction and manufacture means efficiency is an important consideration for the industry. At SGS, our cutting tools are part of the solution, designed to reduce waste and improve the efficiency of the titanium machining process. Thanks for watching, and I will come back with other minerals. Wait for me.